This week we're going to talk about MetPy 1.6. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I want to talk about something exciting, which is a MetPy release. So right after the last MetPy Monday, MetPy version 1.6.0 was released. I want to show you a couple of the neat things that are in it, and then over the next few weeks, we'll of course get to play with some of those. Looking at the release on GitHub, we can see some of the highlights are consistently using the WMO definition of relative humidity across calculations, introduced some new calculations such as wet bulb potential temperature, Graffiti MCS, DCAPE, and Galvitz-Davidson. There's some improvements on isentropic interpolation if you're using something like the WRF output that's not on a pressure surface. There are some improvements to the simplified plotting interface, like style options for lines and map styles. Some projection support for Python 3.12, and then, of course, lots of bug fixes. And we're going to come back to talking about Python 3.12 as well, because there were some interesting decisions that were made that are going to result in warnings about things that are going to be removed. And it won't be for several years, but one of those being the UTC now function that we all use so much. So we'll talk about that in a future MetPy Monday. But for now, I just want to highlight a couple of the new features. The first being downdraft CAPE. So this takes the pressure, temperature, and dew point. We're normally using downdraft CAPE when we have a profile from a balloon or a model. And it is the downward convective available potential energy, or downward buoyancy, that's available to a descending parcel of air. So this is very similar to the CAPE calculation, and that we're looking at the difference between the environmental and parcel temperature and integrating. We also have the Graffiti storm motion, so you get upwind and downwind developing MCS storm motions using the Graffiti method, and of course we've got the reference if you'd like to go read that paper, and a small example as well. There's also, we've had wet bulb temperature for a little while now, but now there's wet bulb potential temperature. So it's taking the pressure, temperature, and dew point of the air and calculating first the potential temperature, or theta E, and then using the Davies and Jones 2008 formulation for wet bulb potential temperature. And there's also a new example, which is a really nice showcase of how you can take a lot of Python things, put them together, and go from a simple plot to a more complex plot to a really complex plot, but without adding really too much complication, just adding more things. So we're getting our upper air data. We've done lots of this, and creating a simple skew-T log P diagram with a hodograph. So you see that doesn't take much code at all. We're using a secondary axes for the hodograph. But now, notice they say a few simple tricks, and we're adding lots of things like parameters that are calculated. So there's some calculations going on in here. There's lots of figure text getting added. And eventually you get a skew-T like this. So we have the basic skew-T. There's some nice alternating shading across the isotherms here if you like that style. There's a legend. We have the hodograph. This layout's also just a little more tight, more efficient use of the space. We've got the 0 to 12 kilometer wind. And we've got the bunker's right moving vector here. And notice they've also colored the hodograph. And then we have this whole box, this whole axis, where we're putting parameters that have been calculated on, such as storm relative helicity, sigtor, supercell composite, total totals, K, all the different capes, surface base, mixed layer, most unstable. So you can see, again, by taking pretty basic concepts, but applying them and putting some effort into the layout, you can get these really, really nice looking plots. And this was a great addition to the example gallery in MetPy 1.6 because it really showcases what you can do with a little bit of determination. So I hope you're excited about MetPy 1.6. Don't forget to go install it. We, of course, recommend using Conda. MetPy is available via the Conda Forge channel. You can pip install MetPy as well. I hope that you found this useful, and we'll see you on next week's MetPy Monday.